Now I have Dr. Diganta Barman, Head Water Resource Division of Northeast Space Application. I would request you to talk about the data, particularly the humongous data, which you have something else?
Good afternoon, everyone. Both the dignitaries on the dais and off the dais, senior officials who are sitting there, and ladies and gentlemen. Actually, when I was communicating with Alice regarding presenting in this forum, so it was told to keep it specific as a smart water supply grid, which is, to be frank, not my domain of hard interventions. I am basically a surface water hydrologist, or if I need to be really precise, I am a riverine water hydrologist rather than an urban water hydrologist. So that is why, so if you see the global distribution of water resources, these are very common and knowledge to all, but still to set the context of the presentation, I'd like to tell about it, that only hardly 3-4% of water actually is available for us, and that it becomes a really difficult task for us to how to manage that water resources so that we can leave clean water for our future generations to continue. So looking at India's water resources, we have an average precipitation of around 4,100%, and we have a deficit scenario till 2050. So that is the reason why we need to be really careful in deciding our water resources. Now coming to the urban water crisis, almost 55% of the world population in cities are facing this crisis. 68% it will become by 2050 as per the projection goes. And similarly, India, 21 major cities may go out of groundwater because of the over-exploitation of groundwater. That also, nowadays government have recently come with some regulations to, just like our building permission is needed, similarly the groundwater exploration also, people cannot do just like that. So that is a welcome step actually we need to see. Biggest problem in groundwater exploitation is that even for domestic uses also, people are so greedy that though they have constructed the well for their personal purpose, but when they saw that the yield is really good, they ended up commercializing that and using it to give it to the tankers and all those things. That is had really proven difficulty in the groundwater scenarios. So coming to the urban water grid, there is a traditional system, there is a modern system. So we are mostly, today we are discussing on the modern system. It is having an active integrated demand driven system. And all the previous speakers have spoken about the development of the AI or use of AI as well as telemetry based sensor network for a efficient water supply system where we can reduce the non-revenue generating waters to do a revenue generating water perspective. So coming to the smart water grid, it is basically a 24/7 pressurized supply, reduce NRW, I have already spoken about it, and it should be energy efficient. These are some generalized picture. So what should be the key components? Basically the key components should be a smart metering system, followed by pressure flow sensors, then metered areas. SCADA, everyone has spoken about. Without SCADA, we cannot do anything. It is the most important thing about any modern water supply system. And then GIS-centric asset management. And predictive analysis, already my previous speaker has already spoken in a very good way actually. We are really appreciating the way he presented without any slide. And all the points he has made are really eye-openers for all of us. So congratulate to you, sir. On the consumer portal and mobile apps. So why geospatial technology is needed? I am basically from the remote sensing and GIS application from the Northeastern Space Application Center. We are a ISRO center in the Northeast, nodal center for the 7 Northeastern states plus Sikkim. So since water networks are inherently spatial and we need to do GIS integration of all the pipelines, both surface as well as subsurface. As someone spoke about ground penetrating radars, these are of course the new technologies that has been integrated with the GIS maps for finding out those pipelines which are below the ground and to have a proper database and a control room system for the overall integration of the entire system. So now coming to the technologies that are currently being used, I think Madhurya sir has already spoken about some of them, though it is little bit in other contexts, but here also predominantly these are the things which are mostly using. We are using some kind of indices also, like normalized difference water index. Similarly for the urban growth, to find out which are the areas which are waterlogged or which is having a high soil moisture content. Similarly, we are using the light detection and ranging, synthetic aperture radar. So now newly the NASA ISRO synthetic aperture radar has been launched and the initial data is out. They are really promising in nature, both in both the bands, and they will also be used in future for urban water supply management. And then WebGIS and GeoPortal is the buzzword actually. So today also in a breakout session we discussed about with Autodesk regarding how the geoportals as well as the dashboards will be coming up in future, and how we can think about all those things. Some of the GIS tools, as we all know, in the open source it is the QGIS is mostly used, and on the paid source we have ArcGIS. Now the enterprise GIS is the current solution which most of us are using in the GIS domain. Now let us come to the distinct phases of development of a smart water grid. Which should be the distinct phases. One is the geospatial planning and feasibility, that should be there. Second one, phase 2 is our network designing using GIS. And third one is the asset digitization. What are the assets we already have and what are the gap areas where new assets needs to be created. And the fourth phase is real-time monitoring of the dashboard, in which I think the agencies like Autodesk etc. can play a really huge role, and that we might be discussing in future. So leakage detection using the geospatial technology is one of the applications where people can think about, followed by the predictive maintenance and risk mapping. Then some global success stories are Singapore has implemented the 100% smart metering, and they have reduced their non-revenue water to less than 5%. Similarly in Denmark they have used the climate resilient grid. And Barcelona also they have hugely used the GIS based leak reduction from 32 to 16%. So these are some of the studies or some of the implementations that has happened globally, apart from what our sir has presented in Mumbai and other places. So now some initiatives in India, because so far as the database creation, as sir has rightly asked me, this Amrut mission ISRO DOS is playing a big role for developing a database at the 1:4500 and 1:5000 scale for the major cities under the Atal mission of urban rejuvenation. So that particular data also can be a very good baseline database for the upcoming water supply systems. And then what can be the quantifiable and the tangible benefits if we can create a good urban water supply system? That will be NRU reduction. If we can reduce it to 15-20%, it will be a good success to start with. And then the energy saving, leak detection time should be reduced from days to hours, and previous slides. Now what are the challenges? Challenges are basically the legacy data, I think already spoken by our esteemed previous speakers. And then the skill manpower shortage, both in the soft component as well as in the hard component. And then the cyber security is also another. Every day we get news that foreign hackers are trying to hack our critical infrastructure, websites and geo portals and all those things. So despite of a good amount of cyber realm security, but still the challenge is still there, and interdepartmental coordination is also another challenges. So with that we can go for National Urban Water GIS standard with OGC compliance, and then capacity building programs, of course everybody will agree to that. Public-private partnership is always a good thing until and unless the size is manageable actually. If it is a regional scale kind of a exercise, then in that case I think I personally feel, this is my personal feeling, pure government should be the only stakeholder, because regional level exercises, public-private partnership have not yielded good results. But if it is a local level or the little bit manageable size of a project, then I think PPP model is perfectly okay. So now coming to my own slides, actually what are the things which we are actually doing in Northeastern Space Application Center? Hardly 2-3 slides I am showing. That is, one is that we are developing the decision support system for reservoir operations for the hydroelectric projects. As of now, we are doing it for 2 projects of NIPCO in Northeast, that is Ranganadi project and Kopili project. Here basically we have done a mesh of automatic weather stations connected through telemetry, both GSM as well as dual telemetry system, followed by a downstream sensor network. We are basically using the river level sensor as well as surface velocity radar, because I personally feel that if we don't get the discharge directly from the sensor, then sometimes because of not having good quality rating curves, we are very difficult to convert our actual data to calibrate the models which we are basically using from the observed data. Because most of the time our model gives the discharge, and the validation and calibration we only get the levels. So that is why I have been focusing this on various forums also, that though the costing is really high to develop a RTDAS of predominantly of the discharge station, but still sooner or later I think it will be realized that though the costing is high, but we will be able to do an accurate job with the good mesh of discharge network rather than the level networks. So similarly, we can do scenario generation on the submergence for flood cushioning. In fact, it is a little bit difficult to discuss that kind of things. Transboundary threats are there for us, especially in the Brahmaputra Valley. You can understand whom I am referring to. So that is why we are working on some projects that if this water is used as a some kind of a weapon from the transboundary side, then what kind of reservoirs, etc., we can create to for that short period of peak discharge peak to accommodate, so that slowly it get decimated, and our cities like Pasighat, etc., which were at the forefront of getting washed away, can be saved. So similar kind of works also we are doing. So at the same time, we are there is a flood early warning system in operational in Brahmaputra and Barak Valley, that is called FLUES. We are doing it for almost last 1.5 decade. And similarly, we are also doing the hydraulic and hydrodynamic modeling using the LiDAR as well as the other high resolution vertical data sets. So that's all actually. This is a bathymetry which we did a combined study with UAV based optical data as well as echo sounder based multi-beam echo sounders, and we have decided how much siltation has taken place and what kind of mechanical approach can be taken for the flushing of the reservoir to regain some of the live load by putting the suspended sediment back to the stream below. So that kind of application we are doing. So similarly, these are the area capacity curves we have developed. And these are the departments actually we are collaborating as of now. We are collaborating with all the state disaster management authorities, Northeastern Council, Ministry of Donor, and Northeastern Electric Power Corporation, of course. Then Water Resources Department of the all 7 states of and plus Sikkim. Similarly, we have also played some role in developing a Sikkim Water Resource Information System under NHP. That is our recent engagement with NHP. Recently, we have completed the project and submitted to Government of Sikkim. So, I think to conclude, GIS technology is not an add-on only, but it is a foundation for tomorrow's smart urban management, grid as well as overall water sector development. So this is our center. I invite everyone who, if you come to Northeast, then visit our center. We can develop future areas of collaboration. Thank you so much.
Thank you, Dr. Barman. Dr. Barman's presentation was twofold. One was, as was asked, about the smart water grid, where he talked about the scarce water resource, the crisis in urban water in various cities that we had in the past, and why the geospatial technology should be used, and smart city grids, smart water grids and its elements. He also talked about the leakage detection and how to reduce the NRW. He also mentioned about the PPP and the capacity building. Particularly PPP in water is a very critical subject, since water is a politically very active, and people in India feel water is free. The moment you introduce PPP, one has to pay, and I really appreciate that unless you pay for something, you don't value that. So now pressured and metered payments are come, like my city is doing, we are doing that. I think that's very important. Unless you start paying for it, you don't value, and then only the PPP models would be successful. Then he talked about what his center is doing, particularly in Northeast, about flood control and other various projects. It was a good insight into that.